All right, here we are on example 5 in section 6.7, partial fraction decomposition. This one has an irreducible quadratic factor. I don't know if I can even spell that. Irreducible. Ugh, I don't think that's right. Quadratic. My computer is not letting me write fast. It's turning it into a mess. All right, you get the idea. So, I'm going to clear that out. Oops, did I delete the whole thing? No, just added a new page, which made me think I deleted the whole thing. Yay. Okay, so let's go back to our first page of notes, and we're going to look at irreducible quadratic factors. Actually, I think that ended up on the top of the second page. So for irreducible quadratic factors, we have to have a linear numerator. So instead of just a over our quadratic formula, or quadratic factor, we have to have ax plus b or cx plus d over that quadratic factor. So we have a linear over a quadratic, so that they're just 1 degree different between the two. And then if we have repeated quadratic, irreducible quadratic factors, then we have to repeat it just like we did the linear ones. So here we are back on example 5. We have, it's already factored, which is nice. So our equation is 5x squared minus 5x plus 5 over x plus 2 x squared plus 1. So that will be a over x plus 2, because that's a linear factor, so it's a constant on the top. And then it will be x plus c over x squared plus 1, because of that being a quadratic, irreducible quadratic factor, so we have to have a linear in the numerator. Okay, so then we multiply by our least common denominator. Computer's being very sluggish, and it's very annoying me. What do my kids call that? It's lagging, something like that. So that part cancels, this whole thing cancels, doop doop. And then here we have x plus 2 times x squared plus 1. That part goes away. Okay, so we have 5x squared minus 5x plus 5 equals a times x squared plus 1 plus bx plus c, the whole thing times x plus 2. All right. Convenient x isn't going to work great on this one, because if we, for example, let x equal -2, we can at least find a, I guess. That might be worthwhile. So 5 times -2 squared minus 5 times -2 plus 5 equals a times -2 squared plus 1, and then this part with the -2 will turn into 0. Okay, So that gives us 4 times 5 is 20, plus 10, plus 5, so 35. And then this is 4 plus 1, which is 5. So A would equal 7. Alright, so kind of like we've done in previous steps, we can plug that back in for A, and then that will help us to figure out another way to do this, probably with grouping our terms together. So I'm going to plug 7 in. I want to make that purple. Plus 5 equals 7 times x squared plus 1. I should maybe just distribute that. So that would be 7x squared plus 7. And then I'm actually going to FOIL this part together. So I'm going to go bx plus c times x plus 2. So bx times x is bx squared. Bx times 2 is 2bx. And then cx. And then 2c. I paused and cleared out a bunch of programs running on my computer to try and fix the lag, and I don't think it helped very much. I'm still struggling with writing with this lag going on. Maybe it would be worthwhile to reboot my computer before the next video. But I always think, oh, that'll just make it take so much longer. Alright. So if we gather up our terms, we will have 5x squared. Here, let's just call this the x squared terms. So 5 here. And then on this side we have 7x squared and bx squared. So solving for b, we should have b equals -2. Okay, then our x terms will be -5. Alright, so we have -5. And then x terms here we have 2bx. So we could solve this by substitution. We already know what b is. We could plug that in there. So that would be a -4. We would add it over here. So I think c would equal -1, right? I didn't write that out because writing with this lag is really annoying me. So let's see if we can use our constants to actually accomplish the same thing, just to check the work. So for our constants we have 5, and then we have a 7, and there's x's on all of those, so then we have a 2c. So if we subtract the 7, we would have -2 equals 2c. So that does confirm that c equals -1, right? Alright, big picture here. So we have a, which we found earlier was 7 over x plus 2. And then we have b, which is -2, plus c, so I'll just do a -1 for that, over x squared plus 1. So there's our linear fraction and our, linear denominator, constant numerator with our linear numerator, irreducible quadratic denominator.